Hey guys, today I'm going to be going over problem 50 in chapter 16. The problem is a helium neon laser beam has a wavelength in air of 633 nanometers. It takes 1.38 nanoseconds for the light to travel through 30 centimeters of an unknown liquid. And our question is, what is the wavelength of a laser beam in the liquid? First, we want to start by identifying our known information. So the problem gives us that the wavelength is 633 nanometers. The time it takes for it to travel through the unknown liquid, which is 1.38 nanoseconds, and the displacement or the distance it travels through the liquid, which is 30 centimeters. We also need to know that the speed of light is 3 times 10 to the positive 8 meters per second. To solve this problem, first we want to solve for frequency, and we do this by using velocity, which in this case is c, our light constant, and the speed or velocity is the wavelength times frequency. So since we want to solve for frequency, we rearrange it and we get that the speed of light divided by the wavelength is 4.74 times 10 to the positive 14 hertz. And now to find the wavelength in the liquid, we take this frequency and we are going to use that same V equals the wavelengths times frequency. And since we know that velocity is some distance divided by time, so we are going to substitute that in, and we get that d over t is equal to the wavelength times frequency. We are rearranging for the wavelength in liquid. We get that the distance traveled over time times frequency will give us the wavelength in the liquid. So 4.59 times 10 to the negative 7 meters will be our wavelength in the liquid. And then right here, to further explain what just happened, so in the air we had a wavelength of 633 nanometers, and when it traveled through 30 centimeters of some unknown liquid, our wavelength was now 4.59 times 10 to the negative 7.